And I'll turn it over to you. Thanks, Tyler.
All right, thank you so much, Hannah. Appreciate it. Let me go ahead and share my screen now. All right, everyone can see that, right? Perfect.
Yeah.
Okay, I'll go ahead and begin. As Hannah said, this is Empowering Data Quality, and I'm Tyler Haire, an Associate Data Engineer here with Management Performance Hub. So I'll do some more introductions here for us. So I'll introduce, myself, I'll give a little more background. Also give more background about the agency. I imagine most of you have not really heard of Management Performance Hub. We're a very small agency here at the state of Indiana, and even people in state government don't even know who we are. So definitely give you some more background about all of us and what we do. First, a little bit more about me. So I was born and raised here in Indiana. It's actually pretty interesting if you draw like a big, maybe 75-mile circle from where I was born, where I went to high school, where I went to college, and now where I work. It would all fit in that circle. So I'm about as local as you can get. And like Anna said, I got my 2 undergrad degrees from Purdue University. It's computer science and data science. So it works very well with what I do here, since it's very software related with data science tools in essence. And I'm the newest data engineer here, actually, on our data management team. So I believe actually just a week ago, I celebrated my 1-year anniversary with the team. So this is sort of like a review of what I've done since I came on board. So it's pretty fun. And since I've been here, my role has been pretty focused on internal process improvements. And even though a ton of my work has been data quality, a lot of what has stemmed out of data quality has been these sort of internal tools that we've been able to use to improve our own processes. So as you'll see, as I explain later, data quality is very much meant for other partner agencies to use to assess their own data. But a lot of what has come out of it has been helpful for our own agency directly as well. So speaking of our agency, Management Performance Hub, what is it? I'm sure, like I said, a lot of you don't really know what it is or what we do. So here's this very long-winded explanation. I'll let you guys read that if you like, but I'll sum it up here for you. We've only been an agency for a couple of years now. So since 2017, we were enacted by state law, and that established our agency and the Chief Data Officer of Indiana. And essentially what we're doing is we are partnering with other agencies. So we're an agency that serves other agencies to help them do their jobs better and just serve the public better. We also will partner with any public entity. So that can be universities or public researchers, and they don't have to be in Indiana either. They can be outside of the state. So I believe we've had data requests that go to like Ohio State University and other external state universities like that. So if you guys see anything here and you're not from Indiana, feel free to still reach out for through some of the links that will be provided, because we partner with everybody and try to help everyone the best way we can. So along with that, here is our mission statement. Again, it really just boils down to us improving outcomes for Hoosiers, and that is done a lot through data-driven decision-making and data-driven policy-making. I like to boil it down and say what we do are these 2 core things. We do these data requests and we do these data products. So data requests are these one-time deliverables. Think about if you get a CSV or something in Excel, that's what a data request would come as. It'd just be when researchers usually need just a big set of data that is comprised from a bunch of different sources, we'll pile it all together and give them a big CSV for that. And that's a data request. But the main bunch of our work ends up being these data products. So these are these long-term projects. They're usually funded either by the state or by the federal government even. And they usually end up being these dashboards or these comprehensive reports that just provide as much insight into all different manner of subjects. So that really shows how we are the state's data partner and really just anyone's data partner. We merge all these different data sets. We provide these insights. We're leveraging technology the best way we can. And we're really uniquely positioned to turn data into insights and drive these public policy decisions just because of how much different data we see, being sort of this central hub where a ton of different Indiana agencies have their data flow through. So if you were to go to our website, you would see this on the front page, and it sort of gives an overview of a lot of the different areas we've done work in. So you can see we've done it with opioids, education and workforce, COVID, and plenty of other projects. So that's just a quick review of sort of everything that we have done these big data products on. And then you can also see we have a data hub. So if you want just data sets directly to do your own work with, you can go to our website and you can see and download these de-identified data sets. So another big part of what we do is making sure that there is no identifiable information. So even though we have tons of citizens, Hoosiers here, Indiana residents, we have their data. We're not giving that out to any of these people we're partnered with. We're de-identifying it, making sure no personable and identifiable information is part of this data that goes to researchers or to other agencies to do some work. And we also have a transparency portal, so that's where more of those products will live. Then an enhanced research environment, which is, again, another way and another set of tools for people to use and to help get good insights about their data. So now that you know a little bit more about me, a little bit more about NPH, we can get into the meat and potatoes of this. So what we're going to go over today is really these six things. So we have what data quality is in terms of its importance, what it is and is not, NPH's solution in our development process to help better data quality across the state. We're also going to do a live demo of our data quality dashboard, the sort of overview one that a lot of agencies will see when they end up going and getting access to the data quality dashboard. Then we'll talk about how we can ensure data quality, both as developers and as just people who fill out and create data all the time. And then, of course, at the end, we'll have that Q&A session for anything that might not be clear or anything I can provide more information on. So with that said, we can dive right into data quality's importance. So data ingest is at an all-time high and growing. I don't think that will surprise anybody. Just in terms of Google, in terms of Chat GPT, just in the last year, there is just hundreds and millions and billions and trillions of rows and cells of data that are constantly being created and consumed and processed. And if you don't know what that data is, it's not very useful. So just having all that means you really have to know what it is. And these massive data sets mean they end up being far beyond human comprehension. So even a data set as small as a couple thousand rows and a few columns, you're not going to be able to look at that. No person can look at that and really describe everything about it, at least in terms of usable details. So, aggregates, all these important measures that end up coming out of statistics and data science, you can't do that at the human level. You need to have a lot of information about the data. And that's why this data can often be seen as this gray box, where a black box in tech ends up being this system where you have inputs and outputs, but no way to understand what happened in between and how you got there. So when I say data is a gray box, it's data being too big to be human comprehensible, but still having access to the data means it is possible to understand it, but not all at once and not by just a single person. You need tools, you need assistance to do so. So all that being said, it's hopefully obvious to see that the need for these valuable metrics about data is growing, and it's probably growing faster than the data is, which is really something to be said considering how much data is constantly being created. See the little graphic down there? All your phones that you're using, all the computers you use throughout the day, that's constantly creating data that's being either sold off or collected by the websites you're using, the apps you're using, all that. It's all being put in these massive data storage farms. And if you don't have data quality, you end up getting to be that guy right there at the right, who you're just shrugging, you don't know what's going on. You have no idea what the data actually is comprised of and how to use it. So our role here with this data quality tool is to help turn that shrug into the light bulb moment so that whoever owns the data or whoever is looking at the data really understands what it is and can make valuable decisions based off of it. And that leads us to the point that data quality ends up being these pillars to knowledge and pillars to decision making, because it is what's holding up the ability of these data owners to actually do or to gain knowledge from their data or to actually use it and make decisions, whether they are a business or a public entity like who we normally serve. So also, we need to importantly talk about what data quality is not before we can get into what it is, because there can be misconceptions, especially because we don't own pretty much any of the data we use. We actually just get it from other agencies and help service them with that data. So there's a lot of stuff that we can't actually do and don't want to do. So first thing, the data quality is not, what we're not doing is we're not changing data. If we get a square, we're not turning it into a box, because as people who don't, or as an agency that doesn't own the data, if we change it, then it's not going to reflect potentially what the data actually is, because we've gone in and we've made changes. So that's why we wouldn't want to change the data. Also, if the data we're getting is not a direct copy of what the data that the data owners have is, then we could potentially be making changes to data that's already had changes made to it. And then if we go out and make those dashboards and those data products that I mentioned earlier, then we just have compounded changes that potentially do not reflect their real world data. So we'd never want to change data because we don't want to provide incorrect insights and We don't want to have data owners think that there is a data there that they didn't create, but all of a sudden now exists. As part of that, we're also not pointing fingers. This isn't a way for us to go back to agencies we partnered with and say, hey, you guys, you've made this data, it sucks. We don't want to use it. You shouldn't use it. That's not the whole point of this. The point of this is provide just more insights about their data. Like I said, we're an agency that serves other agencies. So as part of that service, we want to make sure they are doing the best job they can. And the way to do that is to give them pointers or just, red flags about when things might not be up to snuff and might need some improvement. Same idea, we're not a barrier to progress. This is not our data, as I'll reiterate many times. So we are not able to tell agencies or anyone using the data what they can and can't do with it. If someone gets this massive data set and it's low in data quality, we want them to know that, but we also can't just say, hey, don't use it. But we can say, you probably want to either review this data a lot first or clean it up, or even maybe hold off until the data is better altogether. Analogy, oh, yeah, go ahead.
Can I just ask a clarifying question from the chat, which is, can you explain what you mean by changing the data and maybe give an example?
Yeah, so you'll see a lot of data quality is about creating a score, and there's places where you could interpolate based on if there's data missing, so to speak. So we'll get into completeness and how data quality is, or that's how a pillar of data quality is completeness. It's one of the metrics, and that's just about missing data. So interpolation would be taking the data you have and filling in the data you don't have. That's something we would never do, because then there's data that has been put into that system that is no longer an actual representation of the data we received. We would just say, hey, there's data missing here. We wouldn't actually go in and fill it in. If the data owner wants to go in and fill it in and then give it back to us, that's on them, because that's their data and they're allowed to do that. But we as an agency would not do that. There's other ways to change the data too, but that's probably the simplest example. Hopefully that clears it up. So yeah, I think that went through, or that it covers the main points of what data quality is not. So now we can talk about what data quality is. So I mentioned it earlier, completeness, but now we can go through all of these. So there's essentially these 6 to 7, depending on how you break it up, pillars of data quality, metrics, dimensions, there's a bunch of different terms for it. Additionally, these dimensions have slightly different names depending on where you look. So for instance, I believe duplicates might be uniqueness, something like that. So depending on the sources you're looking at and where you're going, if you try to dig further into this, you might have different names for each of these dimensions, but overall what they're capturing and the actual meaning of them stays the same. So don't be surprised if you see slightly different versions of this, like accuracy and validity sometimes is also compressed into just one metric called correctness, but for our sake, we've separated them, but still use them in conjunction. So to actually say them all out, we have completeness, accuracy and validity, relevancy, freshness, consistency, and duplicates. And I've sort of spoiled it, but these end up being the pillars to data quality, just as data quality was the pillars to knowledge and the pillars to decision making. You end up having these 6 pillars of data quality themselves, because these are really the building blocks of what data quality is. And now that we have all these dimensions, we need to go through, we need to define them, explain why they're important, and provide mathematical definitions. Because I mentioned that there's scores associated with each of these, so we'll be able to see the math that goes behind it. So you'll see this sort of format for all the dimensions we're about to go through. Like I said, definition, why it's important, and then a mathematical definition that I might touch on, just if you're more interested in how we got to the scores that we'll see later when we go through the dashboard demo. So for completeness, it's the first one. It's usually the easiest one to understand. It's the extent to which data has all the relevant and necessary information for its given purpose. It's really usually just, is data there or is it not? If it's not, it's usually incomplete. If it's there, it's usually complete. Like I said, it's one of the simplest ones to understand. It's important, of course, because the only way to actually understand the data you have, or to understand and draw conclusions from data, is to have the full set of data. You need to make sure what is being analyzed is fully represented there. And then that mathematical definition, usually the way we tier this is we do it by column, and then we do it by table, and then we do it by agency. So depending on who the subject is, who's using data quality, they might obviously not do it at the agency level, but they might do it at a similar aggregation. But usually it goes column to table to the highest level. So now I'll provide an example, and we'll see this table a lot. Usually you just need to focus on the highlighted section. So here you can see we have two boxes that are highlighted. One is completely empty. So again, it's easy to see that is missing data, so data that would be incomplete. And then we have another box that is null. So null in computer terms, if you're not familiar, is can be the same way to, or just a way to represent nothing, just empty data. So a lot of the cases will mean if it's null, then it needs to be there. For date of birth, everyone has a date of birth, so that is obviously missing data. Everyone has a last name, so then again, that is missing data there. So that is a simple example. Then you have unintuitive examples that can lead to a bit of confusion and why it can really highlight the importance of why we have to have really open lines of communication with our agency partners. So it comes down to what is expected. So here we have null again, which again can represent just missing values. But when you have certain true false values, Boolean values, things that are either yes or no, true or false, that sort of thing, sometimes the way to represent false is more efficiently done with null than it is to actually put false in the system. I don't know why that is specifically, but it just is how some agencies and some data owners, even outside of the public sector, decide to represent false. So this is where it comes down to, does null equal false? If so, then we have complete data. If null does not equal false, then we have incomplete data. This is where you need these, like I said, real open lines of communication, really good, like clear data dictionaries and ways to ensure everyone is on the same page when it comes to understanding their data. Otherwise, we have a lot of confusion here about if this is actually complete data or not. So if anyone has questions, again, you can go through all this again during the Q&A part. But now we'll move on to our next dimension with accuracy. So definition for accuracy is how, or to the level in which data represents its real world counterpart. So is that data accurate to what it's actually representing? Importance, of course, inaccurate data is going to be very misleading in terms of creating statistics. It also might just prevent meaningful calculations altogether. If all the data is inaccurate, then all the conclusions you would draw from any of those stats that come out of it would probably be useless. And then again, that mathematical definition there, we go column level, table level, and then agency level. So if we look at the same table, but now different row highlighted, you can see there's me there. I was not born in 1950. If I get to look like this in my 70s, I'll be proud of that. Again, also not my phone number. None of these are real phone numbers or real data of anyone. This is all just representations. But again, this is data that does not represent the real world counterpart. So that's me, but it is not my correct data. It does not represent my real world values that are supposed to be there. So very similar to accuracy, we have validity. And these get confused a lot. And even I sometimes slip up and say the wrong one because they're so closely aligned, which is why we combine them. So the definition we would describe with validity is the extent to which data conforms to the standards of its specific domain, which essentially just means format. Is it formatted the way you expect it? So whenever you are filling out, say, like a birthday field or a phone number, usually it'll auto format. It'll force you to type it in a certain way. That's when we're talking about validity. It's not what you actually put into the data, or it's not the data you put in, it's how you enter it is the best way to think about it. So importance for this usually comes down to the people who are using the data. So it can be correct. It can be accurate data. But if it's in the wrong format, the computer in the database might not understand what it actually is. And that's, to the same tune of being inaccurate. So mathematical definition, same thing, columns, tables, agencies, just basically number that are correct versus incorrect. So if we look at a validity example here, like I said, phone numbers are a common one because there's a bunch of different ways to write a phone number. So here you can see in this column, most of them are written in different ways. So knowing which way is valid would be key to understanding, at least for the computer sense, what the best way is, or what the actual numbers here are. So you have dashes, you have ones with no dashes, you have ones that have parentheses and dashes, a mix. Hopefully, however the data is being collected would prevent this from happening, because otherwise it is very time consuming and just very tedious to actually fix this sort of problem. So we'll go over the difference between accuracy and validity here again, just because it is a little bit convoluted. So again, it comes down to format versus content. So if we look at this expected data in format of a phone number, we'll say we have the first 3 digits, that's the area code. Then we have a single dash. Then we have the first 2 digits of the phone number, a single dash again, and the last 4 digits of the phone number. That would make up the format. and the actual numbers in there would be accuracy. So the first example there is accurate but invalid. So that is probably a real phone number. I wouldn't recommend calling it, but it does not fit the format we just defined above. So it's using parentheses instead of dashes. There's no dash in between the second set of numbers. So it is a valid, or sorry, again, easy to slip them up. It is an accurate phone number because the data is correct, but it is an invalid phone number because the format is incorrect. So on the other side of the coin, we have valid but inaccurate. So all zeros is not a phone number, but that does fit the format. We have 3 digits, then a dash, then 3 digits, a dash, and then 4 digits. So format ends up being correct, making it valid, but the actual data it's holding is incorrect, which means it's inaccurate. So hopefully that makes more sense. Again, any questions, feel free to ask them at the end. Now we'll move on to relevancy though. So it's the extent to which data is useful across different systems or different targets. So data is not static, it moves across systems all the time. That's the whole point of collecting it, so you can use it, which means it has to go through many different stages in its life cycle to actually go from being collected to being used. So importance just means if you're collecting a bunch of data, or the reason it's important is if you are collecting a bunch of data, then you want to make sure you're using most of that data or all of it, ideally. So to look at an example, it's pretty hard to show an example just on a static image. The idea here is in this data set, the one that sort of sticks out is not making sense is shoe size. Why would you have shoe size if you're just trying to get people and their dates of birth and their phone numbers? So assuming that shoe size is not used at any end of the system, in this example, then it would be irrelevant. If for some reason this shoe size metric is actually used somewhere, then it is relevant. So it's really just, is data used? That's what makes it relevant. Another simple one to understand. Now we'll move on to consistency and freshness. I believe this is the second to last one here. So how we would define this is twofold. So first, how new the data is its freshness, and specifically how new it is in regards to how new you expect it to be. So like a census is only taken every 10 years, so you would never expect, or if the data is 6 years old, that's not unfresh data. It's still fresh because that's within its life cycle. If the data was 30 years old, then that's non-fresh data anymore because you expect it to update every 10 years. And then that same logic follows for daily, weekly, monthly refreshes of data. And for consistency, it's making sure data is the same across different data sets, specifically data that is referring to the same subject. So if you are in multiple different data sets, it's making sure that all the information that is the same across those data sets matches up to each other. And again, we have mathematical definitions for how we would define these and how we calculate the different scores. But let's look at an example for this one now. So in blue, we have consistency, and in yellow, we have freshness. So in the first data set, we have John Smith there in the top row. Then the second data set, we have John Smith again. We can see he has the same information except for his phone number is different, and the refresh date, which is how you would define how fresh the data is, are 10 years apart. So we have a whole decade between these. So this is where we would say most likely data set 2 is going to be the fresher example or it is the fresher example. So it's most likely that data set 2 has the accurate and valid data. Because it's newer, we're expecting it to be the most up-to-date and the most useful data. It's not always guaranteed, which is again why we wouldn't change the data. Like we wouldn't go back, and even if we could, we wouldn't change the first phone number simply because we don't know if the second one is actually the true phone number for John Smith. So now we can move on to our last but not least in metric and duplicates. So this is often referred to as uniqueness. So definition, pretty simple, the measure of repeated instances of data, that can be either row-wise or column-wise. And then the importance is unintended duplicate values can break processes. They can also create misleading statistics. I think if you're doing like a sum, but you have a bunch of duplicated values, then that sum is going to be way overinflated. Or even in our case, we have the way we de-identify things is we can't have duplicates. So it will actually break our process if we have duplicates. So we have to ensure no duplicates at all in our system. And I'm sure in other systems as well, that is very important. So if we move on to an example, we can see actually 2 examples here because duplicates can be very easy to understand, but also gets much more complicated to calculate depending on how you define it. So the first one at the top will have these perfect duplicates. So in red, we have Billy Joel here. He's repeated twice in this same data set. All the data is exactly the same across every column and the rows, which means it's a perfect duplicate. It's very easy to find, and it's very easy to remove the one that is duplicated. However, if we look at an imperfect duplicate at the bottom one here, you can see there's multiple different ways to get imperfect duplicates. So these are probably representing the same person in Roger Waters. But we don't actually know that because certain key statistics are different. So we can see the name is flipped in the name column, and that can happen based on data entry. You know, sometimes people have, or data entry systems have you put your last name and then your first name. So if someone's not paying attention or just happens to slip up and do the wrong one, that's how you can get that, where you have the names that are flipped. Same with date of birth. In America, we usually do month, day, year, whereas pretty much everywhere else in the world, I think, does day, month, year. So if you have an international system, that's where you can get dates of birth or any other date can be wrong. And again, where the format becomes very important, and you need to make sure everyone's on the same page there. So there's just examples of how you get duplicates that are not perfect. So we call them just imperfect duplicates. Those are much more difficult to figure out because you need a lot of context around the actual domain you're working with. And a lot of computation has to be done to even find those. So those can be very difficult to find. But overall, perfect duplicates are quite easy to understand and to find. So those are the ones we try to focus on the most. So that covers data quality. So again, put this back up for you, so you can look at all those metrics again. And now we will move on to how MPH has created a solution, or our version of a solution for this, at least at the agency level, so that we can help empower all of our agency partners to have the best data quality they can. I just want to reiterate too, we're very uniquely positioned here at the state government, as a lot of data flows through us. So we are in the just perfect spot to actually do this data quality work, since we see so many different data sets from so many different sources. We can really see how they might differ and help provide much more overarching solutions to the state as a whole. So let's move on to our solution and our tools to combat any runaway data quality that might present itself. So we can look at our development timeline from the past, so how this all came together. So the first one there, bottom left, the data management and data science team managers, they created these proofs of concept for the data quality work. Like I said, from our position, we can see all this different data, and many of our team members have years upon years of experience looking at this data. So they're able to tell, like, hey, maybe this is something we need to look at. And from there, with those proofs of concept, we were able to create these initial dimensions. We coded them in Python and a little bit in SQL. And then we also did some dashboard mockups, because all the code is just for us, so we can actually calculate all these scores. These mockups for dashboards and dashboards themselves are what the agencies are going to see and how they're going to actually make decisions based on what we have coded. So as time moved on, we coded more of these dimensions. We created full actual Tableau dashboards. So imagine a lot of you are familiar with Tableau. We use it to create a full mockup of a dashboard that is actually fed by live data. And now currently we have all dimensions coded. We're continuing to do dashboard development. And we have a full pipeline created. So this is metrics we actually run every single week across tons of data. So every week we're getting updated scores for data sets, and we're starting to help agency partners really understand their data quality. So again, about the pipeline, we can look at this final product pipeline at more of a high level. So at the very left, we have the agency partners. They're the start of all this, since they are the data owners. They supply us data. It can be daily, it can be weekly. There's a ton of different cadences. Data is not guaranteed to mirror the source. So that is a big caveat with what we're doing, since we're not the owners and we don't always have access directly to their data. Sometimes we'll be giving data quality on data sets that might not reflect what's actually in their system, which is why we want what we call direct database connections. That allows us to directly see into their database, as the name implies, and gives a much more valuable metrics. So we get data from different, or the sources that are provided by these agencies partners can differ. So we have those direct database connections with some, but some will just give us flat files. So essentially like a CSV, like how we would do a data request, the agencies will do for us. And that makes it a lot more difficult to do analytics and all that sort of stuff, because we don't have the actual data as it's changing and updating in an actual database system. But anyway, that's just to say that all this data is not guaranteed to mirror the actual source at any given moment, just as a caveat. But usually it does if it's a direct database connection, and that means we can put it through our data quality tool, and all those data sets get reviewed because we don't want to put in data sets that don't actually get refreshed. So the first thing we do with our tool is we make sure it only gets fed in data sets that are refreshed with some sort of cadence. So like I said, daily, weekly, monthly, that sort of thing. But we do get a lot of these data sets just as one-time ingest on our end, whether it needs to be fulfill a data request or some random thing that happens and we get random data. We just want to make sure we're not putting that in data quality since score will never change. So once we get all the data sets that are to be reviewed for its refresh or that are refreshed, then we score the dimensions and we process them once a week. That gets outputted to the Tableau dashboards, which is updated via those data sources that we created with the tool. And importantly, each agency can review only its own data quality metrics. So even though we work with a lot of like public sector, it is still private within each one of those agencies, since a lot of this data is personable and contains information directly about people. So each agency only has access to its exact agency dashboard. So I also want to talk about some development difficulties we've faced. I sort of alluded to it in the last slide. But first, we'll start off with how to make this, or how universal are we going to make this tool? So it comes down to software versus pure analytics. A lot of what we have done and continue to do in terms of those data products is more on the analytical side instead of being actual software, whereas this has sort of become more of a whole software suite for us. So it's sort of this new avenue for MPH and a very cool sort of space to explore as a state agency, working with other state agencies. So that was the key question, is like, how universal do we make this? Are we going to be providing direct support for every single agency? We're like, we can't do that. We don't have the manpower. We're a very small agency. So we had to make it as universal as possible and make it this sort of software piece. So, and then also performance. Part of making it universal means we had to do it in Python versus doing it in our database. So we have our own database system, of course, since we have tons of other databases that we're connecting with. And doing analytics in a database system is far, far faster and far more efficient than doing it in Python. But like I said, we have our own system, and other agencies, even within the state, all have their own versions of a system. It's not unified. So if we made tools that only worked in our system, there's no guarantee it would work in the systems for any other agency if they wanted to use our tools directly. By making it in Python, we can actually just package it up and send it out to agencies if they want to run it directly on their system without our intervention at all. Also, part of doing Python and part of that performance consideration is sampling versus population. So if you're into statistics at all, then you'll know that samples can be a great way when there's too much data to compute, great way to understand the data. But for some of our metrics, duplicates specifically, samples don't really work since you need row level data. So we had to really figure out some efficient ways to run these massive data sets. We have data sets that are in the hundreds of millions of rows. So making sure everything ran as efficiently as possible while still being as portable as possible was a big part of the development time of this. Then how to handle those less desirable data sources. Like I said and alluded to earlier, a lot of times we don't have direct connections to the database system. We just get these flat files, which make it a little more difficult to work with. But we still try to do our best. And then delta loads versus full table refreshes. So delta load means instead of doing a complete drop and recreation of a table with new data, you just give the new data and the new updates to the data and to the system as what we call a delta load. Full table refresh is what I just mentioned, that you drop the entire table and reload the entire thing with all the new data. That's what most of ours are, which makes it very difficult to see how data changed without reprocessing the entire data set. And with tables that end up being hundreds of millions of rows and gigabytes worth of data, it is very difficult to process all that again and try to figure out what has changed and maybe how the score might be affected. So ideally, we would get these direct database connections, and we would get these with delta loads for every single system we connect to, because that would allow us to very easily run these calculations, because we only need to run data quality on the delta load and then can update the scores accordingly, because we'll know how many new records there are, what records have changed, all that. So it makes it pretty easy to recalculate everything and update any scores. Whereas full table refreshes, we have to redo the entire processing of a table.
Tyler,
So speaking,
can you just clarify again for, sorry, could you just clarify again for Evelyn in the chat, what data tool are you referring to specifically?
data tool for, you mean just like the whole data quality tool? Sorry, I'm confused by that question.
Evelyn, maybe you could clarify your question, or we could come back in the Q&A. Data
Yeah,
validation,
when it says
data validation tool.
data validation tool. Oh, like validity for that sort of sense, like the metric specifically. Because this tool here, when I say how to make a universal tool, that's like the data quality tool in like its entirety. So the entire pipeline where we ingest the data, process it, and then make the dashboard, that's what I mean by tool here. Talking about validity specifically, it's about just the rules of the data set. So we have to know the data owner and know what is supposed to be in the data, and then with validity and to validate it, we can make sure only that those types of values are appearing in the data set. That would be validity. But if that answers that, we can move on to the stats. So here's just some stats about what all was developed and what all went into development. So hundreds of man hours in development time between me and Brent, the data scientist, Brent Surgeon. And that ended up processing gigabytes up to terabytes worth of data. So for reference, a terabyte of data is 250 movies, 90,000 songs, or 6.5 million PDFs. So it is a lot of data. And we do that, I don't know if we do terabytes weekly, but we have definitely processed terabytes worth of data in the development of this tool. So hundreds of billions of cells and multiple instances of people asking what on earth I am doing, because I am slowing down the entire system and making things not run as quickly as they should. That is the amount of processing power that goes into all this. And we have pretty powerful systems here at MPH. So the fact that we can slow them down with just our data that we have access to is a testament to how much work is going into this. So I mentioned Brent. I'll mention some other key contributors here to this. So Mita Pradhan is the data management team manager, my direct supervisor. Then Brian Zakzek, the data science team manager and principal data scientist, they sort of spearheaded this and brought it up as a key issue and a main goal of last year, and now moving on to this year, of getting more data quality work and more metrics out of the data we have, since as we saw earlier at the very start of this, all the ingest and creation of data is at an all-time high, and we see a lot of it. So they realized the need for this and sort of put Brent and I on the development side to do this. So yep, again, Brent Sargent, the data scientist who helped develop a lot of these tools, and then Ty Codwell as well. He's a BI developer. He is the reason the dashboards have any existence at all. He's had a lot of input in how we've made these, so props to him for that. Speaking of the dashboard, we will now hop over to the dashboard demo. So hopefully this appears. We all can see this. Connect real quick. So this is a quick overview of the dashboard demo. There we go. Can you see the dashboard demo or no?
Yes.
Oh, we can. Okay.
Oh, well, sorry. I see the slide. I'm still on the slide, so no.
Oh, let me make sure and go back to. Let me share the correct screen. I guess I was only sharing that one. You share. I think it. All right, how about now? Can we see it now?
You stopped screen sharing.
I thought I should select one. Now?
I think you're still not sharing your screen. I think you have to click screen share again, because I think you came off of it.
I keep clicking it. I don't know why. Screen share. Stop sharing. I don't know why it's not letting me share this screen. Yeah, when I click on it, nothing happens now.
when you click on share screen?
Yeah, nothing happens.
Oh.
It's worked last time. I don't know why it wouldn't
Worked
work
last
now.
time and it worked yesterday.
Yeah.
So you've come off of you've already stopped screen share and tried again.
Yeah.
Okay. Let me try screen sharing my screen and see.
Sorry, everyone. I thought that would.
Can you see my screen?
Yes. So I can see yours.
All right. So I'm going to stop screen sharing. And maybe let's see if you can try again.
Let's see.
Something always does go wrong with the demo, Julia. You're absolutely right. That happened yesterday with us as well. Our speaker was doing an AI demo. So it happens every time.
This is really weird. Yeah, I keep clicking it and just absolutely nothing happens. I can click the little arrow and like change the settings. But when I actually try to share, it does not work.
Maybe if you wanna quickly sign in and sign out and sign in again, we'll just wait for 30 seconds.
Okay.
Billy,
Yeah.
Billy, maybe you have an idea, Billy.
Yeah, Billy has a solution.
Sometimes there's in the new Zoom, there's a dialogue you have to click when you're recording, and that prevents you from hitting buttons. You could check on your screen and see if you have are you okay with the recording button? And then you click that, and then you can click the other buttons. I don't know if that's happening for you, but that happened to me last week.
Let me also
I see the
pause record.